So now, as a continuation, we are given a rectangular photo, and this photo is placed inside a border. It has a border around it, or a frame in a loosely translated language. So now, if you check, we are having a rectangle here. So the best way for us to win around this thing, we can safely say, okay, looking at this thing, we are having two areas, area of a photograph and the area of a board. So we can say, let's find the area of a border. What was the area of the border, excluding that of the picture? So for us to win here, we can set up multiple equations. So for us to win, we will simply say, okay, what is the area of this particular border? We'll say, okay, this border has y plus 4. This one, we are getting it from this. This is the whole of this, it's y. Then this side is 2, this side is 2. So you add the 2 to give us the length, multiplied by our breadth. In terms of the breadth, we are having 2 this side, we are also having 2 this side, but in the middle we are having 2. So I mean x. So the whole of this, it's x plus 4. This is the area of the border. So we want to exclude the area of what? The area of the photograph. So we'll say minus xy. Remember, this xy, we are getting it from length times breadth, or breadth multiplied by length, to give us 208. This is what it will give us. So from this we will have yx or xy plus 4x plus 4y plus 16 minus xy to give us 208. Then quickly after this, we'll have a 4x. Remember, these two here, they will eliminate each other because they are like terms. So we remain with 4x plus 4y to give us 208 minus 16. We take 16 to the other side, or we transpose. So we'll have 4x plus 4y to give us 192 when you punch in your calculator. So we take out the common factor of 4. 4 into x plus y equal to 192. So we divide both sides with 4, so that at the end of the day we remain with x plus y. So x plus y, 192 divided by 4 will give us 48. Will give us 48. So you have shown what they said you must show. So now, moving forward, let's go to question number 2, which was the simplest of them all. So now they are saying to you, consider the sequence 1, 4, 11. We are having 1, 4, 11, 22, and 37. We are supposed to find the next two terms. So to find the next two terms, first and foremost, you ought to find the first difference, which will not be common, obviously. We are having 3, 7, 11, 15. We don't know the next term. So to find the next terms, this is what you simply do. You'll say 7 minus 3, which gives us 4, this side 4, this side 4. Now you'll say 15 plus 4 plus 37. 15 plus 4 plus 37 to give us 56. So still, you are still going to find the differences. So in terms of differences, it will go that way. Thereafter, you check. When you say 4 plus 19 plus 56, you are obtaining 79. Therefore, the next two terms are 56 and 79. These are the next two terms. So now, moving forward, to find the general term, or the nth term, or Tn, You will simply deal with it in this particular fashion. We need A, we need the value of B, we need the value of C. So to find A, is 2A equal to the value of D over the common difference. So we will have 2A equal to the constant difference, which is 4. Then we divide both sides by 2. Ultimately, our answer is just A equal to 2. Thereafter, we quickly go on to find the value of B. B is just 3A plus B equal to, these things, they are going in this order. We are using this particular order. If we don't have this, we were going to use other things related to 2A equal to D, positive 3A plus B. I hope you understand. So we are going to equate this thing to positive root of 3. So we'll have 3 into positive root of 2, positive 2, close bracket, plus B equal to positive root of 3. So this is 6 plus B equal to positive 3, then B equal to negative root of 3, because we are going to say positive 3 minus 6, which will end up giving us a negative. So we'll have A plus B plus C, we equate it to positive 1. So we'll have 2 plus into, whenever you see a negative, place it inside the bracket, plus C equal to 1. Sorry, this is negative 3, sorry. So this will be negative 1 plus C equal to 1. So C is equal to 2. Therefore, Tn, or the nth term, is 2n squared minus 3n plus 2. This is the general term as it was required. This is the general term, this one. This is how you find the general term. So now the question says, how many terms of the sequence will be equal to? How many terms of the sequence will be equal to? So what you simply do, you take the value of Tn. It's 2.1.3. So here they've given you the value. They actually want the position. It will be at which position? They just want the position of that particular value, term value. So what you simply do, you take your Tn, you equate it to 301. So we will end up with the general term, which is 2n squared minus 3n plus 2. You equate it to 301. So from this basic approach, similar to equations, you'll put it in standard form. This is 2n squared minus 3n. Then 2 minus negative of 301. You will end up with negative 299 equal to 0. Thereafter, you quickly factorize. You quickly look for factors. This will generate 2n. Also, this other side will have n. Now we equate everything to 0. Two numbers that you can multiply to get 299 is just 13 and 23. And remember, these two, they are closer to one another. At some point, they will lead us to obtaining negative of 3n. So this is positive. This is negative, this is positive. So the value of n equal to 13, or n equal to 23 divided by 2. And not just 23, but negative. So we cannot have a negative position. So we'll say, therefore, n is not equal to negative 23 divided by 2, but n is equal to 13. So it's 13 terms. It's 13 terms. So let's quickly proceed on to other questions. Now we are at question number 2.2, wherein they say the third term of an arithmetic sequence is -7 and the seventh term is 9. Determine the first term and the common difference. So now with these ones, it's more or less simple. 2.2.1. If you follow the information given as it is, you'll discover that you already have answers here. They are saying the third term. Remember, when you are dealing with arithmetic, the first term is A, the second term is A plus D. The third term is A plus 2D. It will continue in that particular fashion. So now they are saying you need to find the first term and the common difference. So the common difference between these terms will be common, will be the same. So you just simply say, okay, the information given, let me act like someone who does not know. You'll say A plus 2D to give me -7. Then this thing that you are having here, but when you check, you are also having A plus 6D to give you 9. So you can set up some equations here, because when we check, A will eliminate each other or the first term. So you'll simply say, okay, A is equal to -7 plus 2D. I meant to say minus 2D. This is negative, sorry. Let me quickly erase this thing. So we will write this one as A equal to -7 minus 2D. We call this one equation number 1. Then we also have A equal to 9 minus 6D. You call this one equation number 2. So if you check, they have something in common, so you can just say equation 2 equal to equation number 1. You simply solve this thing. You will have 9 minus 6D equal to -7 minus 2D. Then you group in the like terms. You'll have -6 plus 2D, -6D plus 2D, which will give us 4D equal to, then you transpose -9, I mean 9 to the other side, you'll have negative and negative, which will give us, will end up with -7, and we will also have we'll have -7. We'll have -7. Sorry, this is -4D. Sorry, we'll have -7, which will give us -16 this side. Then we divide both sides with -4 and the -4. Ultimately, the value of D will be 4. So to find the value of A, you just substitute inside any equation between 1 and 2. So you just say A equal to -7. I'm using the first one, minus 2 into 4, which will give us negative root 15. When you calculate, it will give you negative root 15. So we are done with the first aspect, or the first part. So now let's quickly go on to the second one. Let's quickly go on to the second one, which is 2.2.2. They are saying find the 51st term of the sequence. So to find the 51st term of the sequence, after doing what we have done, we already have the value of A, we already have the value of D. So we know that Tn should be A plus into n minus 1 multiplied by D. Then what is the value of A from the given information? The value of A is -15 plus n minus 1 multiplied by 4. So this will simply give us -15 plus 4n minus 4. Then this will just give us 4n minus minus 19. So to find, this is Tn, this is Tn for that arithmetic. So to find the T51, it's equal to 4 into, where you see n, you substitute 51. 51 minus 19. 51 minus 19. So when you punch inside your calculator, you will discover that your answer is 185. The answer should be 185. And still, we could have substituted everything on this step. We should have substituted everything on this step. Still, we were going to win. So we are done with those ones. So now we want the sum. When they say sum, it means somewhere, somehow things have to be added. So because this one, it is an arithmetic, we just have to use sum to n term formula. We just have to use sum to n term formula. So if you check, they are saying sum to 51 terms. So already we have term number 51, or the value of the term that is at position 51. So you'll just say sum to 51 term equal to, you deploy the formula wherein you will have to use the last term. You'll have 51 divided by 2 into the value of a, which is negative 15, plus the last term, which is 185. Remember, this approach, we are taking it from this sum to n term equal to n divided by 2 into a plus l. This is the approach that we are utilizing here. We already have the 51th term. So sum to 51 will be 51 divided by 2 into 170. Ultimately, this will give us 4335. This is the sum that you were supposed to calculate. Now, let's jump on to other questions. Let's jump on to other questions because we still have a lot to cover today. So now we are looking at the third question, which is sum of the first n term of an arithmetic sequence is given by. So now they are saying sum to n term is given by 5 divided by 2 n squared plus 7 divided by 2 n. So now such questions, like majority of times when they come, they will require you to find a term. They will require you to find a term. So now the question says find T1, or the first term. So to solve question 3.1.1, this is how you solve it. To find T1, T1 is equal to sum to one term. So you will simply say T1 is equal to 5 divided by 2 into 1 squared plus 7 divided by 2 into 1. When you punch in your calculator, you will end up with 12 divided by 6 to give us 1. Sorry, this is 12 divided by 2 to give us 6. This is term number 1, or the first term. So in terms of the common difference, you are simply going to check, okay, I am having sum to one term. This is 3.1.1. The best approach here is to check, okay, I am dealing with sums here, right? I'm dealing with sums. But we know that sum to two term is given to us by T1 plus T2. This is sum to two terms. So do we have sum to two term? We don't have. So if we quickly find sum to two term, somewhere, somehow, we will win and we will end up finding T2. So let's quickly find sum to two term. Sum to two term will have 5 divided by 2 into 2, you square it, plus 7 divided by 2 into 2. Then when you calculate this, you will end up with 10 plus 7 to give us 17. Then quickly after this is sum to two terms, right? So quickly after this, you will say, okay, now I have sum to two terms. So this sum to two terms is given to me by T1 plus T2, right? So sum to two terms is 17. You'll say 17 equal to T1 is 6 plus T2 is unknown for now. Therefore, T2 is equal to 17 minus 6. Ultimately, we remain with 11 for T2. But remember, the question says the common difference. So to find D, to find the common difference, it's T2 minus T1. So we will end up with 11 minus 6. Ultimately, we will have 5 as the common difference. We'll have 5 as the common difference. So from this, they are saying find the 10th term. Find the 10th term, or T10. Now, we are going to use or to utilize the linear method. We are going to utilize the linear method that we are used to. We have the value of A here. We also have the value of D. So what you simply do is to check, okay, what is the general term of this thing? Tn is equal to uh, 6 plus into n minus 1, the value of D, which was 5. Then we quickly simplify this thing, leaving what they said we must find or discover, right? So this will be 6 plus n minus 1. They are saying the 10th term. It means that we are losing one term. So it's more like the term position minus 1. So it's more like 9 multiplied by 5. So we will have 10 minus 1 to give us 9. So we'll have 6 plus 9 multiplied by 5 will give us a value of our interest. Then at the end of the day, we will end up with our answer as, we'll end up with our answer as 51 when you calculate. This is T10. This is T10 because now we are substituting. This is T10, this is our T10. T10 is equal to that which we have there. So now I'm quickly going to erase everything here so that we can deal with the preceding questions. I hope you have copied. So now let's look at question number, let's look at question number 3.2.1. We are having 2 multiplied by 5 exponent 5 plus 2 multiplied by 5 exponent 4 plus 2 multiplied by 5 exponent of 3 plus. These exponents, they keep on decreasing, right? So now the first question says, calculate the sum of the first 8 terms of the series. Correct to 2 decimal places. So now the first thing that you ought to identify, what is the value of A? According to the information given, the value of A is 2 multiplied by 5 exponent 5. Then to find the value of R, or the common ratio, we'll say T2 divided by T1, which will just leave us with 1 divided by 5 when you calculate. Remember, we are going to have 2 multiplied by 5 exponent 4. You divide everything by 2 multiplied by 5 exponent of 5. So it's more like you are saying 4 divided by 5. Like in the denominator, you are going to remain with some elements. So you will end up with, when you punch this value here, this is the value of R. When you punch this thing inside your calculator, you'll end up with R equal to 1 divided by 5. So now they are saying to you, find sum to 8 terms. Sum to 8 terms, we know that sum of a geometric series is sum to n term equal to A into 1 minus R exponent n divided by 1 minus R. Then let's quickly substitute. This is sum to a term equal to what? What is the value of A? The value of A will be 2 multiplied by 5 exponent 5 into 1 minus the value of R, which is 1 divided by 5 exponent 8 all divided by, we divide everything here by 1 minus 1 divided by 5. Remember, 1 divided by 5 is the value of r. Then sum to 8 term is equal to, when you punch in your calculator, should give you 7812, comma 48. Remember, they said you must correct to 2 decimal places, so I have corrected to 2 decimal places. So now, moving on to other questions. Moving on to question number 3.2.2. We are given sum to infinity here, but it starts from 9. Sum to infinity which starts from 9. And if you check, this question is related with the first one. It's related to the first one. So what you simply do, you first go in and check what is sum to infinity. You first check what is sum to infinity of this thing. Sum to infinity first. So you'll check, okay, what is sum to infinity? Utilizing the information that I am given. We know that sum to infinity is a divided by 1 minus r. Then sum to infinity, what is the value of a? The value of a is the same value. It's just the same value. So we will simply have our sum to infinity as 2 multiplied by 5 exponent 5, all divided by 1 minus 1 divided by 5. Ultimately, our value here, we are not finding sum to infinity per se for that problem. We are finding sum to infinity for that which we had initially. So this one will simply provide us with the sum to infinity for this thing will give us 7812,50, because our sum to infinity does not start at 1. It rushes and starts off at 9. So now we have this one that starts at 1. So up until 8. So we are going to subtract. We are quickly going to subtract this thing with something else. So now we check. We do it like this. Let me try to erase this part here. And I need you to understand properly here. You will simply say, okay, this is sum to 8 terms, right? So now we are going to say, okay, we'll say sum to infinity from n equal to 1. This is sum to infinity from n equal to 1, wherein we'll have 2 multiplied by into 5 exponent 6 minus n minus, we want to subtract, right? We subtract what? Sum to 8 terms. We subtract sum to 8 terms, wherein we start from n equal to 1, 2 multiplied by 5 exponent 6 minus n. Now you should check. This one is sum to infinity, which starts from 1. This one is sum to 8 terms, which start from 1. So if you check, the two will go hand in hand or hand in glove. So now we will check, okay, sum to infinity when we start from 1. This was sum to infinity when we start from 1. We said that, I will repeat it. We said sum to infinity of a geometric series, it's a divided by 1 minus r. Then when you try to expand this, you will discover that you are having 2 multiplied by 5 exponent of 5 divided by 1 minus 1 divided by 5, because the value of r will be the same. We subtract that which we have from from up there, which was summed to 8 terms, wherein we will have 2 multiplied by 5 exponent 5 into 1 minus 1 divided by 5 exponent of 8. Then we divide everything by 1 minus 1 divided by 5. Then we make our calculations quickly. Then when we calculate here, when we calculate for the value this side, we obtained 7812,50 minus, we subtract that we have calculated up there, which was 7812,48. So our answer now becomes, translate to, remember here we are finding sum to infinity to 8 terms. This is sum to infinity to 8 terms. So we will end up with 0,02. This is the final answer.